remember when we have those double angles, or if we have sine of 2x, remember that we have to go back and divide by that 2. We have to divide our answers by that 2. Well, if we have that plus or minus 2k pi attached to it, if we have that attached to it and we go back and we divide by that 2, that's going to change this plus or minus 2k pi, right?
Right.
So say we were dividing this whole thing by 2, each of these by 2. We would end up with that pi over 4 plus or minus, it would be k pi now. And this would be 3 pi over 4 plus or minus k pi. So now if you were asked to find all of the solutions between 0 and 2 pi, are these going to be your only 2 answers?
No.
Because we've changed that period that we're adding on, you have to take that into consideration. So that's just a note for these later on problems when we're looking at them. It was something that I forgot to mention yesterday that will become important. So even when I say that we're just finding between 0 and 2 pi, add on that plus or minus 2k pi, and then solve like you normally would, but that's going to generate your list of answers between 0 and 2 pi. That's how you're going to find all solutions. Because before, when I asked you a question like that, most of the time I was just asking you for all solutions in general. Those usually weren't included in the specific interval from 0 to 2 pi. So I want you guys to look at example 2. Given what we did yesterday, you should be able to do example 2. So I want you to try to do example 2 on your own, and then we're going to look at it as a class. But you guys need to start trying to do these problems on your own.
I can survive.
What? Oh. Yeah, you can.
The audio seems don't stop by the train, huh?
Tyler,
Yeah.
work on the example, please.
Not yet.
No, thought he got stopped by a train. So he stopped. Can you send this audio too? I'm just not, I'm over it. I didn't bring my backpack today. I literally think I'm just the whole class in my feet only.
They say you have to take a picture of it. Because your mom doesn't believe you.
We had a 7 first time. We just straight. I'm still feeling. Well, should we go?
If I do not
Oh my god, I had such a different time because I went for 10 minutes. I was like,
I told myself I wouldn't go. I still have a whole month. I'm just kidding. I just want to do it for less. I keep just telling myself push through it. Less, but now.
Oh, yeah?
I just wasted my month.
It's very sad. I didn't watch it. I read a recap.
Yes.
My dad would not waste a big clip.
I dropped lemonade in my phone.
Yeah, I don't know.
Yeah.
I don't know.
I was like,
I'm
it's
trying
so
to figure it
hopeless
out.
to me. And I was like,
My dad is no tea.
what?
I'm very. Smells like
Oh,
so
beer.
So when we do that, no, because that, this sine 2x times sine 2x is not going to be the sine.
So that's assuming
So how do you, so we talked about that yesterday, when we were looking at our.
Yeah, I'm selling my body.
So how about Tyler, work on the example, please.
Alright, sorry, Miss Lane. Just trying to math. Here. No problem.
Are you still?
Now I'm just waiting for you to go over it.
But I want you to try it.
I tried.
Okay, so you got this, and now what else can you do?
Take a bird.
Go sign. Sign that.
So what do you do with that? What were you doing with it?
I honestly can't. These are not responsible.
You have to add this, this,
So if you're doing this, what does this look like?
count that,
Oh.
9 by 7.
Kathy, you're linking up to the back up to the back.
Now this, remember, that does not actually equal that. That's not, this is what we found here. This was what somebody had said that it might equal, but then we actually showed that it equaled that. So here we have that. That's not what it's equal to.
I talked to her yesterday.
Oh, okay, sorry, yeah, sorry, yeah. I got you. Sorry, Austin.
Like, I thought that was true. That's I'm like, no, Darius is like a lot of girlfriends, and that's like part of like what he comes with. He's in theater, she knows that. She's the guy.
When she got so upset about I told her I was do you think like just do you just
Oh, yeah, most definitely.
I was
That's
studying,
serious.
she's not really in a problem. She's going to their party and it's like me and all the problems.
Gentlemen, are you working on the example?
Miss Lee, why do you feel like this today? Can't we just have a rest day?
That's what Ryan I was like, I have
I seriously, he's like, no way, you would shower.
Miss like, when I have a green tea, like I never have one of those situations.
Let me see if I can find
Wake
it.
up at 7. Last year, wake up at 7.
I completely understand what you're saying.
You would wake up early.
Yes.
If you had to jump the gun.
Man, I don't know, one person gets up
Like
at
just
7.
relax, not for a second, let it flow through,
I don't know, I feel like I'm
Oh,
still
and
gonna
this is
have.
last year.
I would still be honest with you, but don't like jump to conclusions, you know what I mean? I think you know the options. Once like, I don't know, for some reason I feel like she'll feel like you know, we'll get back together, you know? I'm not gonna give it a
Supposed to
shot.
get back together.
Gentlemen, the example.
Because he's so into like, he wants to like just live his life right now. He wants to be able to call those down to get
Yes.
advantage
I have
of
a
like
question.
stress them out.
Going to my last day.
As of right now, I have these two final
And I know Gary's even playing
Okay.
on the play.
So what would I do there? Is sign
What are you gonna do?
I just,
sign X, cosine X is
and I
equal to
just
0.
go through more and I'll divide the tail out and make sure.
Alright, anyone else start this?
How bad am
What do you do? Bro, let's do some.
I? Oh,
Oh,
well,
actually, see.
oh,
Let's try some spots on the train.
like she just.
Alright, I'll draw the train.
So when you look at this, when you expand this out, you get this, right?
Yeah.
And then you're gonna move that over, like you did.
Yeah.
If you left
I
it as,
was, how are you, by the way?
She's like,
that would make it easier to solve.
Yeah, but even just like a text message or like a phone call.
No, just a negative 2 sine 2x.
he should have, and he still did because he wanted to.
Exactly, that's what
Because Ryan's trying to do the teaching or whatever, and I appreciated it. I've never been able to do that.
So you would still have this part,
But like, I was
but
telling
instead
her,
of having this, you'd have plus 2 sine 2x.
I feel like do that. We have like every weekend.
That's why I did
And like, we
So write it out.
literally can after just hanging out, we're gonna you can take it. No, you don't. You're allowed. They do stuff. I was gonna say, like just the way they walk in the hallway, I'm like, yep.
Do that you can.
Try to go to and make it. I just, like, I can just
All right, so we're gonna look at example 2.
It's not secret.
We're gonna look at example 2 now.
That makes more sense.
So example 2 says sine 4x equals -2 sine 2x. And we want to solve this equation for all solutions between 0 and 2 pi. If I want to solve this equation, I had options, remember.
Sine
bet-
2x plus 2x.
So you want to rewrite the sine of 4x? If we rewrite that as sine 2x plus 2x, what are we doing with that? What are we essentially rewriting that as?
Simplifying.
So sine 2x cosine 2x plus sine 2x cosine 2x.
So you want to rewrite it using the
Identities.
sign addition identity. So it was sine 2x cosine 2x plus sine 2x cosine 2x. And that still equals that -2 sine 2x. Did anyone do sine 4x differently without breaking it up as 2x plus 2x?
I took it too.
Everyone broke it down first?
Look at that.
Alright, so now I'm going to combine like terms. So this part of the equation that I combine my like terms, does that resemble one of our identities?
Yes.
Which one?
Sine 2x equals 2 sine x cosine x.
So what was that one for though?
Oh wait, no.
No, so Jake, what identity was that though?
That was the double angle one.
So that was our double angle identity. So this sine 4x goes back to what we talked about yesterday. When we were talking about sometimes you'll have other numbers inside here besides a 2. And we developed that pattern. That we could go from this sine 4x right to this. Because we said that our angles inside here were 1/2 what our original angle was. So even without doing this sine 2x plus 2x, we could go right to this part, given our double angle identities. It's okay that you did it this way, but I want you guys to realize that you could also just go straight to this point. So once I get to this point, again, I want to solve the equation. So what were my strategies for solving equations before?
Pythagorean
Huh?
identity.
So that was when we were proving identities. So this one kind of looks like we're proving an identity, but this one actually wants us to just solve the equation. So our variable is that x. So essentially we're solving for x.
So let's
That's what
divide.
we're doing with these equations.
Why don't we
We want to
divide?
solve for x.
We just divide by 2 sine
And once we
2x.
solve for x, just divide the by 2.
So you want to divide out?
Well, you said we're solving for x, so
Yeah.
that's what we would do. We're solving for x.
Okay.
Then you get a -1.
So we'd get a -1 on the other side.
Yeah.
Okay. So if we divide out 2 sine 2x from both sides. We're going to end up with that canceling out and that canceling out. So we're going to have cosine 2x equals -1, like you said, Tyler.
Yep.
So now, where do I go from here?
Well, don't you still have a negative on that side?
So that's my -1.
Oh,
That's what we're equal.
I didn't see you write that down.
Sorry. Huh? So you want to divide out that 2. Is that what you're saying?
Hmm?
Huh?
You wait till the end.
Well, I'm asking you, can I do that?
Sure. You wait till the end, you're trying to solve the equation, you just have to find x, so.
So what do you guys think? Can I divide out that 2?
No.
No,
Why can I not divide out that 2?
It's on the inside.
you have to wait till the end.
You tell them, wait till the end.
So cosine 2x.
So, okay, so you guys are saying that I need to wait until the end.
Connect the cosine.
Because this is all one thing. We can't just divide out that 2.
Oh,
We're
that's
taking
another-
cosine of that.
Yeah, that's another
angle.
identity.
If it was in front of it.
Right?
Yes. Yeah, if it was 2 cosine x, yes, then you would divide it out.
Where-
But where it's inside there, we can't do that.
Okay.
So this goes back now where we're at right here. This should go back to an 8.3 problem.
8.3 problem.
8.3 was a little rough subject.
No, so now we need to solve still for that equal to -1.
Oh, that one.
But what did we do? So Ashley, what did we do?
Previously took. Yes.
So we need to what?
Well, that's what I just took.
Okay, so we graphed it. So where is my cosine going to be equal to -1?
Yeah.
At pi. Because what was my definition for cosine? How did I figure out that it was -1? My cosine equals x over r. So I'm looking for where my x values are -1. And this is where my x value is -1. So when I'm solving this, I get pi. Is pi my answer? Hmm? Okay, so plus 2k pi. But is that my answer?
No, equals 2x.
That equals the 2x, yes.
Plus or minus 2k.
Why, I thought we were only in between the intervals of 0
Yeah.
and 2 pi.
So you missed my little bit at the beginning. For these problems, you want to add that on even though we're between 0 and 2 pi. Because when we have this equal to the 2x,
It's gonna cancel out and be 1 time around.
it's going to be so that's going to move on. So we're going to divide out that 2, right? That's
Yeah.
essentially what you're saying?
Yeah.
So let me do that first, and then that'll kind of help explain. So when we divide out that 2, we get pi over 2 plus or minus k pi now, right? So we've essentially changed what we're adding.
Yeah.
So if you want to find all solutions between 0 and 2 pi, is this going to be your only solution now that we're only adding this? This is going to help us create a list of all the solutions to make sure that we have all solutions. So if we're looking at pi over 2 now, pi over 2 is going to be one of our solutions. But then we want all the solutions between 0 and 2 pi. So how can we find other solutions in between 0 and 2 pi? Looking at this.
Add 180.
So we can add 180. So we're adding multiples of pi. To find other angles in between 0 and 2 pi that still work for this, we can add multiples of pi. That's what this is saying. Is to find those other angles is we're adding multiples of pi. So in this case, if we have pi over 2, and we add pi, what angle do we get?
3 pi over 2.
So we get 3 pi over 2. Is that between 0 and 2 pi?
Yeah.
Yeah. What other angles can we find? Is that all? Just those two? So if we add another 180, oops, that should be the 3 pi over 2. If we add another pi, what do we get? We're going to get 5 pi over 2. And like you said, that's outside of our 2 pi. Do you not know how I got the 5?
No.
So I have to make this pi so that I can add it to my 3 pi. So I'm going to multiply by the top and the bottom by 2.
Okay.
So I'm going to have 2 pi over 2. 3 pi plus 2 pi.
Okay.
So Emily said this one's too big. So that's not in our 0 to 2 pi. So this one is not. So we have those two solutions. Can we get any other solutions? So not without going outside of our area. Now, I want to go back to this because we did make a list now. We've listed our two solutions for this cosine 2x equals -1. But when we did this step, we canceled out. We divided by these 2 sine 2x. We divided that out. Well, what if this? We have to figure out, did this 2 sine 2x have any solutions? Because we divided it out. So instead of dividing it out here like we did, could we have done something else? So we could have what? Factored it out? If we factor it out, don't we have to have them on the same side though? So we would have had that 2 sine 2x cosine 2x. And then we would have moved, so we had to have plus 2 sine 2x, and that would have equaled 0. So now we can do what you said, Emily, that we can factor it out. So we can factor out a 2 sine 2x, and we would be left with that cosine 2x plus 1. And those both equal 0. Now that cosine 2x plus 1 is what we just solved for. But now we have to look at this 2 sine 2x. So if we're looking at, I'm running out of space. If we're looking at 2 sine 2x equals 0. How can we solve that one?
Divide by 2.
So this goes to what you were asking about, Devin. Now we can divide by that 2.
Wouldn't really do much.
It's not going to really do anything, but it's going to get rid of the 2 out front for us. So you're going to end up with sine 2x equals 0. So now we're going to do the exact same thing we did with the cosine, except now we're equal to 0. So how do I find where my sine equals 0? So my sine equals y over r. So where are my y values equal to 0? So my y values are equal to 0 at my 2 points on the x-axis. And that's at my 0 and my pi. So again, I get answers 0 and pi. But are those my answers? So we're going to do the same thing. We're going to plus or minus 2k pi. We're going to add and subtract 2k pi from both of these. But again, gentlemen, I have to set that equal to my 2x. So again, I have to solve for x. So we're doing the exact same thing we did with the cosine.